I'll read the question again for the recording. The mass m of spherical planet may be assumed to be point mass at the center of the planet. A stone traveling at speed v is in circular orbit of radius r about the planet as illustrated. So, okay, so the stone is orbiting around this planet. V is the it's the speed of the object in this particular direction, or यहाँ पे it's attracted to the planet because of the centripetal force. Show that the speed v is given by the expression gm over r under the root. तो simple, you know कि gravitation force. अब इसमें एक ही चीज we can apply, that force of gravity is equal to the centripetal force. Force of gravity is gmm over r square, and central force is mv square over
mv
r.
square over r.
ठीक है, तो r eliminate हो गया, gmm over r बच गया यहाँ पे सिर्फ. Okay, the board just got disconnected. Can you see the whiteboard?
Yes, I can see the whiteboard.
You just give me a second.
Okay, sure.
All right, can you see the screen again? Gee, Hassan, can you hear me?
Yes, I can hear you, लेकिन screen अभी तक नजर नहीं आ रही.
Screen आपको
आ गई है.
ठीक है. So we're looking at this question here. Okay, what I was saying was that you can use this formula. F is the force of gravity equals centripetal force. G mm over r square is equal to mv square over r. So g mm ये कट गया, g m over r is equal to v square. So root on both sides.
v को
So
subtract
v is
करना
equal to
है.
root gm over r. ये हमने show कर दिया. Okay. All right. Now moving on to the next part. A second stone initially at rest at infinity travels towards the planet as illustrated. So now a stone, this is the second stone, it's traveling towards the planet. infinity. It was at zero value. Okay, the stone does not hit the surface of the planet. Determine in terms of the gravitational constant g, the mass m of the planet, the speed v of the stone at a distance x from the center of the planet. Explain your working. You may assume the gravitational attraction on the stone is due only to the planet. So there's no other surf object around that stone that's interfering in the gravitational force. Mass capital is mg is the gravitational constant. V naught आपने find करना है. This is at infinity. ठीक है, this is point of infinity. X is the distance from between infinity and to that point. Remember, we used to we the formulas for electric potential. We established those formulas depending upon the same concept. Okay, you were removing a stone from infinity to that point, any object from infinity to that point. All right. So let's look at, okay, we were also, because considering energy velocity, so we'll also have to look at the kinetic energy changes. So if a planet is traveling towards the surface of the earth, we know that the gravitational potential energy would decrease and the kinetic energy would increase because it's traveling towards the surface. Up now, because the planet is involved, so we'll have to look at it in relation to that planet, because the gravitational force of the planet is affecting the potential of that stone, right? So इसका मतलब ये है कि now let's equate the force, the kinetic energy and the gravitational potential energy. Half mv square is equal to mgh. So mm eliminated. V square is equal to 2gh.
पोटेंशियल एनर्जी का हम फॉर्मूला
सॉरी,
दूसरे वाला नहीं
पोटेंशियल का
लेंगे
फॉर्मूला
जीएम
यूज करेंगे.
ओवर आर वाला.
यस, you're right, ठीक है. हाँ, इसको पोटेंशियल एनर्जी नहीं, जी एम एम ओवर आर यूज करेंगे. या ओके, सो वी स्क्वायर इज इक्वल टू एम तो निकल गया है, जी एम ओवर आर.
को सब्जेक्ट करने
यहाँ पे वो मल्टीप्लाइंग टू एज वेल, 2gm over r. Yeah, so under root 2gm over r. This is the answer. Use your answer in 1 and the expression in A to explain whether the stone could enter a circular orbit about the planet. So what do you think? कि अगर stone is arriving at, let's say, any point around the planet, will it be able to enter a circular orbit?
आई डोंट थिंक सो क्योंकि लाइक स्पीड ज्यादा होती है इसकी.
Velocity जो v omega जो v naught है, it's always greater, right? तो stone will not be able, it won't enter this. देखो जो इसकी this speed v naught is greater than the orbital speed, the speed at which it might orbit around the planet. So the simple explanation could be that v omega is greater than v क्या है, it is the orbital speed. So this is why stone cannot.
दिस इज ऑलवेज गोइंग टू बी ग्रेट राइट, क्योंकि ये कॉमन सेंस वाली बात है कि जो अप्रोचिंग
Obviously
इसकी स्पीड होगी वो ज्यादा होगी.
exactly, projection speed ज़्यादा होगी. तो ये इसका marking scheme भी आ गया. Now look at this graphical question. I want you to read this question, both of these graphs, and then I'll explain. ठीक है? Just a second. Okay. So question 17A, क्या समझ आया? जी Hassan, can you hear me?
Can you repeat the question? आवाज कट रही है आपकी.
अच्छा, the question is कि ये have you read this statement for 17A?
Sketch. Hello, can you hear me?
I can hear you now. Your voice was getting cut off again and again.
Can you explain me the statement? वो point mass
Yes.
वाली बात समझ नहीं आ रही मुझे.
अच्छा, तो सबसे पहले तो um, देखो, what the question says is कि we're talking about the difference of, देखो point mass तो कोई भी mass with any object having its mass concentrated at a point is known as point mass. So we're talking about any point mass, and we're looking at how the gravitational field strength would vary with the distance. So can you tell me the formula for gravitational field strength? हमने formula किया था.
For the gravitational field strength,
Yeah,
it's gm over r square.
Gm over r square. So gravitational field strength, G is Gm over r square. तो इसका मतलब ये है कि
So
the gravitational field strength is inversely proportional to the square of the radius, right? The square of the distance.
yes,
So the
वो
line,
increase करेगा
what's
तो वो decrease करेगा.
it? Obviously, yes, and it's an inversely proportional gradient. इस तरह का, yes. And the line will not touch zero. Remember, it's not starting at zero, and it will never touch at zero on the x-axis as well. This is the characteristic of an inversely proportional graph. The line never touches zero. You get it? क्योंकि अगर एक जीरो होगा तो फिर दूसरा तो हो ही नहीं सकता है आपका, right? इस वजह से this is a standard graph for an inversely proportional gradient. In this case, the square of r varied with inversely to the gravitational field. Okay, sketch the variation with speed of the magnitude of the force on a charged particle moving at right angles to uniform. Acha, you can ignore this because this is related to magnetic field. So we haven't done that topic. We'll just move on. Okay. So let's look at the marking scheme as well. Smooth curve with decreasing gradient, right? Curve decreasing gradient like this, not starting at x equals 0 and not ending at g is equal to 0 or horizontal. Okay.
Okay.
So question number 26, define gravitational field strength. Force per unit mass on a point mass placed at that particular point. कितने
कहीं फिर
marks की
with
definition है? It's a 1 mark definition, so you can just write anything at all. Obviously valid. So force per unit, let's just cover 2 points. It's force per unit mass.
that's exerted per unit mass on a small object placed at a point.
Yeah, तो इसको हम short में से कहते हैं force per unit mass um, acting on an object placed. Yeah. Explain why for changes in vertical position of a point mass near the Earth's surface, the gravitational field strength may be considered to be constant. For changes in vertical position of a point mass near the, yani if let's say this is the surface of Earth and the point mass is somewhere near the Earth's surface and the variation is vertical, the gravitational field strength may be considered to be constant. Why is the gravitational field strength constant and why is it not changing? This is the question. Remember, the gravitational field strength varies when the change is quite significant. हमने पहले बात की थी कि whenever, in order to understand the effect of gravity, you cannot feel it when the object is very close to Earth or when the objects is too close to each other. For example, can you feel a force of gravity between your mobile phone and maybe your pen on your table? No, simply no, because the objects, number one, have very less mass and they're too close to each other. So it's important for the objects to be at a significant distance. This is why. So to have a
The
quantitative
change in
understanding,
height between the objects is really less. That's why.
yeah. So, but obviously you'll have to quantize that as well. Now, ये तो बहुत generic statement है कि बहुत कम है height. So what we can do here is you can consider the radius as an understanding, as a point of measurement. If the distance is greater than the radius of Earth, then you could actually understand the effect of gravity, or that height would become significant. All right. So the statement that you can write here is that the increase in height must be significant, or at least greater than the radius of Earth. Because it's a 2 mark question, you can use some examples, some equations to explain it as well. G is equal to G m over r square, and G is equal to G m over r plus h square. देखो again ये equation कहाँ से निकल रही है अगर हम, because all of the mass of that object will obviously be acting at the center of the earth, right? Let's say this is the center, तो ये तो this is r, and then there's height. So obviously the second equation over here is, it responds to the height plus the radius, and the first one is just about the radius. If an object is, let's say, over here, so the distance would just be the radius. If the object is at point, the new point, that's point B, so now the distance will be radius plus height. All right.
Right. I think like gravitational field strength का formula में GMM तो नहीं होता. GM over R square होता है.
नहीं नहीं अच्छा हम ग्रेविटेशनल फील्ड, हाँ सॉरी, ठीक है, तो
Yes. नहीं
सिंपली इस बात का,
gravity
हाँ इस बात का ख्याल रखना है.
Newton's law of gravitation.
सॉरी कम क्या.
Now continue.
Okay, all right. So yeah, so gm over r square, just remember the point for the first one, because we're only looking at the radius, the object must be on the surface. The second one, because we're looking at the radius plus height, so the object is at that particular value of height above the surface of Earth. Okay, now let's look at part C. The orbit of Earth about the Sun is approximately circular with a radius of 1.5 times 10 raised to the power of 8 kilometers. The time period of the orbit is 365 days. Determine a value for the mass of Sun. Explain your working. So you're given with radius. You are also given with the time period, and you're supposed to find the mass of Earth. Sun, sorry. तो सबसे पहली बात, we know कि gravitational force is
Force is equal to
providing
the
the
centripetal.
centripetal force. Yeah, orbit की
Yeah, तो
बात
वो
हो
हम
रही है.
equate कर लेंगे.
G over r square is equal to mv square over r. तो हमें mass भी पता है, we know the radius as well. Yeah,
और G का constant भी है.
the orbit of Earth about the sun is approximately circle with the radius. अच्छा ठीक है, हाँ तो बस g constant पे हमें पता है, तो we'll just plug in these values और हमें we'll get a value for mass. अभी there's no use for the time period right now. वैसे you can go for the time period वाला formula as well here. It's a 5 mark question. So do you remember that formula? T square is equal to 4 pi square r cube over gm. You can go for this formula as well. Like, you'll have to explain the derivation of this formula. M r omega square ke through, remember? Hassan, do you remember the derivation of this formula? Gmm r square is equal to mr omega square. Omega is q by t. Yeah. Q is 2 pi r by t square. 4 pi square r square over t square. तो 4 pi कट गया. Gm over r square is equal to 4 pi square r cube. R ऊपर चला गया and left with t square. So t square is 4 pi square r cube over gm. Go with this formula. It's easier. Just keep the
या वो
mass.
डायरेक्ट आ जाएगा उसमें से।
Okay. So bas, because the reason why I'm explaining this again is that it's a 5-mark question, so you'll have to show some working. All right. तो अब ये है कि for this one here, question 27, you're supposed to do it. 27, 28 is an assignment, is a class assignment. I want you to do question number 27 right now in class, and 28 as homework.
Okay, let me grab my calculator and my pencil.